In case you're not sure, this is talking about advanced authentication options inside of Postgres. So Postgres has a whole bunch of different authentication methods that you can possibly use. I'm going to kind of talk through the ones that I recommend and that I push for with my clients and other folks I talk to because I consider them to be the most secure, right? There's a lot of complications involved in setting some of these pieces up and getting them working, so we'll go through some of that as well. I guess another quick note, I somehow forgot to put my slide in here, but I'm Stephen Frost, for those of you who haven't met me. I'm one of the Postgres committers, major contributor, hacked on different security stuff. I will be at the Postgres booth probably a fair bit this weekend, so you're welcome to come by and chat with me anytime you want. So when it comes to authentication methods, there are some that I would kind of recommend you should use, right, that I consider to be pretty secure, pretty good. The first one I'm going to start out with is something called peer. Peer authentication basically allows you to kind of make it so that Postgres doesn't need to worry about the authentication question, right? We're going to push that over to the Unix kernel, right? Because we're going to do it over a Unix socket-based approach, where with that socket we can just ask the kernel, hey, who's the user on the other end of this socket, right? And by doing that, we can then say, oh, it's this user, and we trust the kernel has done its job and authenticated that user in some fashion, so we don't have to worry about it. And so when you're thinking about these different methods, right, typically you're thinking about you have like a system user and you have a Postgres user. So in this case, the system user would be the Unix user, right, whatever the Unix username is inside of etcpasswd. And by default, Postgres will have a mapping from that identical system user to the identical Postgres user. You can actually change that mapping, though. We'll talk about that a little bit later if you want to. Another one that is near and dear to my heart, and you'll note that other people poke fun at me about it when I talk about it because it's one I deal with a lot, which is GSS API, or GSS, or also known as Kerberos. Right, so Kerberos is actually what Active Directory uses for authentication, and it's a really strong authentication protocol. And you can use that with Postgres. So you can actually have Postgres integrate in with your Active Directory environment, or if you happen to be at a university or something that's running MIT Kerberos or Heimdall Kerberos, you can certainly integrate Postgres in with either of those options too. And the last one that I really like to encourage is certificate-based authentication, right? And this is when you're using client-side certificates, and then you can actually do things like map the common name from the certificate to Postgres usernames using a tool called, or a configuration file called pgident. So those are the ones that I pretty much stress, and those are the ones we're going to be primarily talking about as we go through this lecture. As I'm going through, definitely feel free to raise your hand, ask any questions you want. I'm happy to answer them. Even with some of these different options, there are things that you want to do in order to make sure that you're using them in the most secure way. Certificate-based, for example, you want to make sure that both the client and the server side are requiring what's called verify equals full. Right? That means that we're actually verifying the certificate entirely, all the way up to a trusted certificate authority, and that things like the username matches the username and the server name matches the server name, and all of these fun little cross checks that you want to make sure you have. GSS is actually interesting because it's got some of those similar requirements now that it's got support for doing encryption as well. So GSS API actually gives you an option for how to for doing encryption on the wire. That's actually new in Postgres 12. It's one of the things I worked on for Postgres 12, in fact. So there's some that I kind of consider acceptable, but I don't really encourage use of them. Scram is actually pretty good, right? I don't like it because it's a password-based method. I tend to much prefer Kerberos or certificate-based, but it works if that's all you've got, right? It is pretty strong even though it's password-based. PAM is really hard to actually get to run correctly with Postgres, so it's acceptable, but I don't really encourage it, right? You can run PAM using something called SSLTLS, which allows you to get around the issue that most PAM modules actually expect to be run as root. You can also use PAM with like PAM PGSQL, which is kind of cute, right? You can have Postgres authenticate against a Postgres database. It works. For this case, you do need to make sure you're using SSL for network security, because the passwords are going to be, well, whatever the PAM challenges are going back and forth will be passed over the wire in whatever form PAM is wanting them, right? Which is often in clear text, right? So it's one of the reasons why I don't really encourage it. But it does, it does work pretty well. Radius is another good approach. This integrates with a lot of your enterprise Radius solutions. Again, you also need to use SSL here. Radius typically is like your one-time password kind of token things. It's usually a way that you can, it was one of the options with Radius-based authentication. You still should encrypt it though, because even though the code is a one-time password, the PIN tends to be reused, right? Usually a user has a PIN that they keep and maintain. And then password is a traditional password-based authentication. This is like, SSH with plain text password tunneling, right? So I put this in here not because I really think people should use it, but it's very traditional, right? It's very similar to a lot of the other methodologies that you'll see out there, like SSH with password-based auth. Actually, it does something very similar most of the time. Methods that I encourage you avoid. MD5. This is primarily because it's deprecated and Scram is where you should be going now, right? MD5, it worked. It was a challenge response based mechanism. So just snooping on the wire wouldn't let you authenticate. But it still is something that you should be moving away from. Don't use LDAP, right? I push on this a lot because I see so many people out there with LDAP deployments, and what are they actually doing? They're using Active Directory, and they're using LDAP, and it's like, no, don't do that. If you have an Active Directory environment, use GSS API, right, which is what Active Directory actually uses, right? None of the Microsoft utilities anymore use LDAP-based authentication methods. It's there entirely as a crutch for things that don't do Kerberos. Right? All of the actual Microsoft stuff does Kerberos these days. It also uses a simple bind connect to talk to the LDAP server, and it proxies the credentials. This also means that if your Postgres server is hacked, right, anybody who is authenticating to Postgres, their credentials are going to be seen by the Postgres server. Even with SSL, right, what you'll end up with is those users potentially giving up their kind of keys to the kingdom, their actual login to the Active Directory domain. Right, which means that you can then go and impersonate them anywhere. So don't do it in development either, right? It's not good to use. I really strongly encourage you to go look at and use GSS API or SSPI if you're running Postgres on Windows, which I don't really recommend, but if you're doing it, you can use SSPI, which is Kerberos native basically on Windows. IDEN is a network-based thing that's supposed to be like peer, but it doesn't do any real authentication of the remote side, so I really don't recommend using it. And of course, trust basically bypasses all authentication. So if you have a line in your PGHPA that says trust, that basically means you're not doing any authentication. There's no validation that the client is who they claim they are. And I don't recommend that because that's not very secure. It's fast, I will give you that. And I have seen people make that case, that it is really fast. And I'm still not a big fan of it, but I get it. Interesting side note about LDAP. LDAP requires that when you connect to Postgres, it reaches out and connects to some other server. Kerberos doesn't require that. Right? The way the Kerberos protocol works, the only thing that's needed is the keytab file on the Postgres server. So it's actually much faster startup time to authenticate with Kerberos than with LDAP too. So here's a basic pghpa.conf file. It's read in order, top to bottom. First match is used. I'm not going to hit on this too much because this is kind of intended to be more of an advanced class. So just realize that there are some options here, things like host SSL, and you can specify what IP address or CIDR mask you allow as a matching line in here. PGIDEN is what you can do for peer or for mappings. right? So remember I mentioned earlier you can have a system user, or in this case an auth user, same thing, and then you can map that to a Postgres user. So you can actually map any Unix user to some other user to have them authenticate as that user in the Postgres database. You can also use regular expressions, but just be careful about anchoring them. So these are what these particular mappings allow. Not every Postgres authentication method allows for mapping. Most of them do. I think one of the interesting ones is I don't think LDAP does. But you can do it with GSS API, you can do it with certificates, and you can do it with peer. So let's talk a little bit about how Kerberos works. Right? Kerberos works by having a KDC, that's a key distribution center, right? And then you have what's called a ticket granting ticket. So the way Kerberos works is that I'm a user in a Kerberos environment, right? I run a command called kinit, right? This is the very beginning of arranging to have Kerberos authentication. That kinit will contact the KDC server, right? And will basically request a ticket from it, right? And underneath what is actually happening is that the password that I provide to kinit is used as a encryption key to encrypt a piece of data, a nonce and a timestamp, right? And that nonce and timestamp and that encrypted payload is what is sent over to the KDC. The KDC has my password. It knows what it is. It will decrypt the packet that it's been sent, and as long as the decryption is successful and the timestamp is within reason, it will return to me another payload, another encrypted payload that's actually encrypted with the Kerberos server's master key and encrypted with my key. Okay? So that when it comes back across the wire, right, I can then decrypt it. Now I can't decrypt the actual insides of the ticket granting ticket because that was encrypted by the Kerberos server's master key, right? What I have is I have an encrypted blob that I know is a ticket granting ticket that now I can take that and use it to ask the KDC for more tickets. Okay? So this allows single sign-on. Once I have that first ticket granting ticket, I no longer need to type my password in over and over and over again. Right? I have a ticket granting ticket. I can just use that to ask the KDC, hey, give me a ticket for a given service. Right? And so that's what happens when you then go to connect to a Postgres database. PSQL, as an example, or whatever you're using to connect to Postgres, will actually go and contact, it'll first connect to Postgres and then it'll contact the KDC and ask for a ticket if it didn't already have one. And then the KDC will provide a ticket for that service, and then we'll send that ticket, the client will actually send that ticket to Postgres, and Postgres will decrypt that ticket using the Postgres key tab file. This all works based around the concept of principles. So we have user principles and service principles. So you as a user would have a user principle, right? Postgres as a service has a service principle. That's at a kind of a high level thing. You don't actually have to stress about it too much because it's managed all for you. The key tab file then contains the service principle, right? So what's happening here is that the KDC and the Postgres server have a shared secret, right? They have a shared secret encryption key, okay, that they both know. And that's what the KDC uses to encrypt the service-based ticket that is then used to prove that you are who you claim you are to the Postgres service. So when you get a ticket for Postgres service, what that ticket consists of is an encrypted blob, which is encrypted with the Postgres key, right? And inside of it says this user is this, this user, right? And it's got a timestamp in it, basically saying, hey, this ticket is valid for this length of time. So now, if you want to do Postgres on Unix with inside of an Active Directory environment, you need to first create a user account. This is going to be a user principal in Active Directory. You need to create a service that we can query against Active Directory to get back that ticket for the Postgres service. And you have to map that user account to that service. So Inside of a Unix system, you're going to then need a key tab file, so you're going to need to create that out of Windows, and then export that and copy it over to the Unix-based system. And in fact, Windows actually has one command that does all of that in one shot. When you're actually running with Kerberos on a Unix platform, it's typically going to be either MIT, Kerberos, or Heimdall. I've tested this out, and it works just fine with MIT Kerberos, which is the default Kerberos library on most of the distributions these days, but I don't think there would be any reason why it wouldn't work with Heimdall if you prefer to use Heimdall. So here's what that looks like when you're creating a service principal in Windows. You have this ktpass command, /out is the key tab file. That's where we're going to end up storing the eventual service principal encryption key that's going to be created. You're going to specify a principal name. This is the service principal. So here I've got this postgres/server.fqdn.com@realm.com. You're then going to have to map it to some user inside of Windows, right, inside of Active Directory. For example, you could call it PG server, or some people would normally put like the host name in it, you know, PG and then the host name or something, or PG1 and then the host name. You tell it to choose a random password, right? One thing you do want to make sure you specify is that the encryption needs to be AES 256 SHA-1. Interestingly enough, there are different encryption options for Windows. Besides this, not all of those encryption options actually work with all of the different Kerberos libraries. This is actually something that was a real pain in the butt when it was first starting out between Kerberos and on a Unix platform and Windows Active Directory. Was Windows had like some encryption options and Unix had different encryption options, but they were both all Kerberos, but they couldn't actually crosstalk at the time because they didn't have the same encryption options. It wasn't really until I think AES 128 that it actually got pretty well standardized between the two, and you could actually do this kind of export with a key tab file. All right, now if you're doing this, so that's creating a service principal on Windows. So this is basically, these are the steps that you need to take. I actually have an entire blog post on this as well, if you want to go read that, which goes through the same steps. One other thing I'll mention here is when you create the actual user in Windows, that's that PG user here, that you're mapping to, you need to make sure you go check it and have it, there's like an option in there that says AES 256 encryption supported. You actually have to enable that on the user itself as well, which is a little silly, but it's Windows. All right, now if we're on top of a Unix platform and we're using an MIT KDC, so this is not if you're using Active Directory, or, and this is one of the other cool things about it, Kerberos supports what are called cross-realm trusts. So if you are the Linux guy at the enterprise that you're working in, and you're like, I don't want to have to go to the Windows people constantly to ask for new service principals or any of this stuff, you can create a cross-realm trust between an MIT KDC that you set up and manage and the Active Directory environment. And what that can be set up to allow is that a user in the Active Directory environment would then be able to transparently to them, they wouldn't see anything different, doesn't matter to them, right? They would be able to transparently access resources managed by the MIT KDC through the cross-realm trust. There's a little bit of setup work that has to be done, but it's not that hard. So in order to use Postgres with it, though, you need a service principal in the MIT KDC. And to do that, you just you use kadmin to connect to the KDC. And then this is all you have to do is just add princ-rand key. This creates the principal inside of the MIT KDC database. And then you need to export the key tab file, which is this postgres.keytab. And then you just copy that key tab file over to the Postgres server. Now, of course, one of the other things to mention here is that this key tab file is sensitive, right? It's the encryption key that the KDC and the Postgres server share. So if that file is compromised, anybody could use it to impersonate anyone to the Postgres server. Now, that's as far as they can go, right? They can only impersonate things to that Postgres server. They couldn't impersonate a different Postgres server because that's going to have a different service principal. They couldn't impersonate a user to any other service, right? Because they don't have the encryption keys for anything else. they only have this one file, and so that only this one server ends up being compromised, which is a big difference, right? One of the things about the way Kerberos works is that the Postgres server will never see the user's actual password, ever, not in any form, right? And that's one of the great things about Kerberos, and it's why Active Directory uses Kerberos today, right? Because it's a strong authentication protocol. Now, in either case, whether you're using MIT Kerberos or whether you're using Active Directory for your KDC, when you install the key tab onto a Unix platform, you need to configure your etckrb5.conf. This is pretty straightforward. In fact, the default often works fine, but there may be a couple of items in there. You have to copy the key tab file to the Postgres server, and it's a binary file, right? So be careful with making sure you transfer it as binary. I've noticed sometimes if you attach it to Outlook, somehow it gets mangled. So don't use Outlook. And then all you have to do is inside of PostgreSQL.conf tell it where the key tab file is using this Kerberos server key file. You could store it in the data directory. You could store it in /etc/PostgreSQL. Just make sure it's only readable by Postgres. You can have it be used by multiple Postgres instances on the same server if you want. You can also not have it be used by multiple Postgres instances if you want. It gets a little bit complicated if you want to change that up because of the way Kerberos looks up which service principal to request from the KDC. Specifically, when it connects, it tries to do a reverse DNS lookup, and then it tries to figure out what service you're asking for. So if you actually are using multiple different services on the same IP address for Postgres, then you're going to have to change the service name, which is an option that you can pass into libpq. Once you've done that, all you have to do is tell Postgres to use Kerberos or to use GSS, right? So you just specify host all, and then say GSS, and Postgres will happily use Kerberos Authentication. On a Windows platform, if you're running Postgres on Windows, you actually just need to do SSPI for that instead. One of the things that I mentioned earlier is that Postgres 12 now includes GSS API encryption, and this encryption basically is only going to work when you're using GSS for the client and the server. It does work with keys that are provided by an Active Directory KDC. You can specifically say you want to only allow GSS connections by doing host GSS. So this is GSS encryption, not authentication. These are two different things. This is encryption. And you can also have host no GSS. And actually, I think it's host GSS ENC now. They changed that. I think we kind of covered all of this. It's basically the same thing under Active Directory as under MIT Kerberos, except that the service principal comes from the SSPI interface instead. When you're running on a Windows environment, you might be wondering, okay, well, what service am I going to have this run as, right, in order for the KDC when you're running Postgres on Windows? So you can set that up by, you can either have it use the computer account, which I don't really recommend, or you can have a dedicated domain account. In order to do that, you have to create an explicit account in the domain, and then change everything to be owned by that, and then you can change the service logon credentials so that Postgres will run as that new account. And then the only thing that you actually have to do special after you do all of that is to tell Active Directory that this domain account is what's now being used for the Postgres service on that Windows server. So that's pretty straightforward. All the key tab magic stuff happens underneath SSPI. You don't actually have to worry about creating your own key tabs or setting stuff up like that. In fact, Active Directory is kind of cute because it can also do automatic key rotation of the Kerberos keys and whatnot for you, which is nice. So this is if you want to use a network service or a computer service instead. But here you can specify that by doing set spn-s postgres to the server name. So this is if you want to use a computer account, or call it a network service if you want. All right, so that's Kerberos. So next we're going to talk about SSL and TLS. So SSL and TLS work based on public-private encryption technology, right, which is very different. So one of the things that you might wonder about, like, why is Kerberos doing all of this like shared secret encryption stuff? Kerberos was around before public key cryptography. It's that old, yes. It has been around for a long time. There are modifications to Kerberos these days that where you can actually make it work with public key cryptography instead if you want. I don't find that happens very much because there's a lot of infrastructure around the shared secret stuff that Kerberos does, and it's perfectly well secure. But in the event that you want to play around with that, there are options for it. Like there's something called PK-init, which is public key initialization of Kerberos. So, but I'm not going to talk about that. Instead, I'm going to talk about regular SSL and TLS. So the certificates need to be public documents that are signed by a trusted third party. This is usually your certificate authority, or also known as a CA. Each one of those certificates has a private key associated with it. So the certificate itself is a public key, right? And then there's a corresponding private key, right? And if you encrypt something with the public key, you must have the private key to decrypt it, right? And then if you encrypt something with the private key, you can decrypt it using the public key, right? It goes both ways. I think I got that right. But the point is that you can actually use it to prove things, right? That somebody signed this, for example. The root CA itself is typically self-signed. Often you have intermediate CAs that are signed off by a root CA, and then you're going to have a server certificate and a client certificate, right? That could either be signed by the root or more commonly would be signed by some intermediate CA. So if you want to do this with OpenSSL, you can create a self-signed CA and then an intermediate CA. I have commands for all this fun stuff. So this is kind of what we're going to walk through, right? You have to create the self-signed CA, the intermediate CA for servers, the intermediate CA for clients, a server certificate, a client certificate, then you have to sign those, and then you have to install all of this stuff into the right places. So first thing to do is set up an OpenSSL based root CA. In order to do that, you have to modify the OpenSSL CNF file to specify this different key usage, CRL sign and key cert sign specifically. And then you can go ahead and create a self-signed CA using these commands here. So this first one just generates a key. That's all it does. This is the private key. And then this creates an actual request with a key and gives you your self-signed root CA. Next we want to do is create an intermediate CA. So to do that, we have to create a server key, or create a key for the intermediate CA, and then create a CSR. That's what the root CA is then going to sign. And then we're going to create that certificate from the results from the CA. Right, so here, this is the key that we're going to generate. Then we're going to create the CSR. This is a certificate of signature request. And then we're going to actually sign it as the CA. And then this is the same thing, but for the client, for the intermediate CA for the clients. But otherwise, it's exactly the same. Once we've done that, we can now create the actual certificate that Postgres is going to use. So here we're going to, again, create a key, and we're going to create a CSR, right? And then we're going to sign that CSR, or create the certificate with the intermediate CA by signing the CA, by using the contents of the CSR. So this is your first step, right, of creating the CSR, and then this is your second step for actually, and this actually, you can do both the key creation and the CSR create in one step. So I'm showing that here by having a key out over there. And then this is the same thing, but on the client side. So here I'm creating a certificate for the client user to have. And here, you know, some of the primary differences here is like the common name. So PG username is the common name for my client, whereas server.crunchydata.com is the server's certificate. Everybody kind of following along about how all that works? So we're kind of building this tree, and down at the leaves we have the actual certificates that the client and the server are going to use, and then they all go up to a single root that both the client and the server are going to both trust. And that's how certificate authority works with Postgres. So now to set that up with Postgres, first things first, you need to have the root CA certificate. You just need the public certificate, right, for this. Because the certificates are signed by the private key of the CA, and we can verify that was the case by using the public key from the root CA to make sure that the decryption works correctly. And then we also need the server key on the Postgres server. Now you do have to combine the certificates together, and depending on the version of TLS, the order may matter. I believe in 1.3 the order no longer matters, but in earlier versions of TLS, order did matter. You also need to make sure you set up proper permissions. Postgres doesn't like it if you try to use a key that's got wide open permissions, understandably. OpenSSH is the same way. So you copy the CA certificate into place, you copy the server's key into place, and then you build the certificate file with the different certificates in the right order for Postgres to use. Now, what's the certificate file actually used for? Right? This certificate file, this server.crt file, is actually what Postgres will send to the client when the client connects. And what that does is that gives the client a way to validate the certificate that the Postgres server is presenting to it all the way up to the root CA that both the client and the server trust. So the server intermediate CA may not exist as being known to the client, and it doesn't have to, right? Because during this whole handshake process, the Postgres server side will send it over to the client, and the client can use that to validate that the certificate was signed by a trusted CA. The configuration parameters you have to configure in Postgres are pretty straightforward. There's just a few of them. You have to set SSL equals true, set your cert file, set your key file, and then your CA file. Now, one thing I'll point out here is also that be careful when you set your CA file. Any certificate in there is going to be considered a trusted root CA by Postgres, even though you might stick something else in there that isn't actually a root CA. So be a little bit careful with that. I don't recommend doing that. I do recommend setting up a CRL. Setting up a certificate revocation list is a real pain in the butt with OpenSSL, so I don't have it here. Sorry. It's only a 45-minute talk. But I do recommend using one. And most CAs that you actually interact with out there will have a CRL for you to use. So what do you do in the HBA file? So in the HBA file, you should be setting host SSL, and then you want to say cert, right? And what that'll do is that'll actually use client certificate is required, but this will actually use the common name from the client certificate as the authenticated user in Postgres. You can actually go further than that, though. You can actually have a client certificate required, but then use Scram for authentication, which is kind of nice. So you can say, okay, client, you have to have a valid certificate, but we're also going to do password-based authentication over top of that. In some cases, this can be considered two-factor authentication for use cases that require two-factor auth. In V12, we're also getting some additional capabilities where you can also specify verify full for that, which is important if you actually are using that certificate. So you want to be on version 12 if you want to use Scram with certificates. Otherwise, you can just use client-side certificates, and that works quite well. On the Postgres client, you need to take a number of steps to make sure that the Postgres client is going to be able to authenticate to the Postgres server. So again, you have to have the root CA because both sides need to have that trusted root. You then also need the client key over on the client side, and then again, you need to put the certificates into the right order. Now, this is corollary to the other side, right? The client needs to have the client intermediate certificate, CA cert, in its certificate list so that it can then send that to the Postgres server, and the Postgres server doesn't need to actually have that client intermediate CA in its configuration at all, right? It doesn't care about that, right? All it needs to know is that there is some path of signatures that go all the way back up to a trusted root. And that's what the client intermediate CA provides by sending it on the client side to the server. Of course, permissions matter here as well. These are maybe a little bit overboard, but I always use 600 when I can. The only thing that actually has to be 600 is the key itself. Now that's not all though. On the client side, you need to also make sure you use what's called verify full, right? And this is to make sure that all of those cross checks and verifications are actually done. By default, Postgres is kind of like, well, we're going to try and do it, but we're not going to complain if it doesn't verify. So when you're writing these applications and you're using these things, you really need to make sure you're specifying verify full, and you want to do it on both the server side and on the client side. The cert auth method also has a verify full option when you're configuring your pghpa.conf. You can also use an environment variable instead by exporting this PGSSL mode and setting it to verify equals full. And then once you've done that, you can just, PSQL-H and off you go. So there are other options. Verify CA, for example, will only check that the certificate is signed by a trusted CA, not that the server that you're connecting to is the server that you said you wanted to connect to. So when you do PSQL-H here, I'm saying I, as PSQL, want to connect to server.crunchydata.com. If you just have verify full, then the server, Postgres server, as long as it has some certificate that's signed by a trusted CA that the client trusts, it'll be accepted as a valid server, right? Whereas if you specify verify full, then the client, PSQL, or anything using libpq with verify full, will actually go and say, okay, does the common name in that certificate match the host name that I tried to connect to? Because those two things actually do require, you want those two things to match up, because otherwise you could end up with somebody impersonating you or going through some kind of man-in-the-middle type of attack or issue, right? And you don't allow that. And that's what I've got. You didn't ask any questions, so it was a little quick. So we have some time for questions now, or we can all go over to the expo. Yes? Good? Yeah, go ahead.
Is there a use case for verify CA?
Why would you not use verify full? If you have a very small installation, right, if you have your own CA that you're managing, maybe you don't want to be locked into making sure that the clients are always connecting to the same exact host name, right? And I can think of some various reasons for why that might get annoying, to make sure that that matches up. And if you have a very small environment where you trust yourself and you trust the CA to only have signed certificates that you care about, that it's not a good reason if you ask me. Like if you care about security, I think you should be using verify full, absolutely. But that would be the justification for it that I could see someone making. Yes?
If you don't have a CA that you've created yourself and you're using something signed by
Somebody else, yeah.
real world authority,
Mm-hmm.
is it just you refer to the operating system standard list of trusted CAs, or?
So yeah, so Postgres is able to use the OS level OpenSSL stuff, right? Because we just use OpenSSL underneath. Yeah, we just use OpenSSL underneath. So yeah, that isn't a problem. You can have it use that, certainly. If you don't want to create your own CA, which I can certainly understand. Other questions? No? All right, well, I'm going to let you all go then. Thank you all for coming.